Hello, future users, subscribers, viewers, and students. There is a problem on the construction of shear moment, shear force, and bending moment diagrams. I hope that through this video, your knowledge and skills in statics will be enhanced, making you a better and fine student in engineering, particularly civil engineering. So here is the problem. Construct the shear force and bending moment diagrams for the beam ABCDE. So this is the original beam, and for the segment AB, it has a load of varying load of from 0 to 36 kilonewtons per meter. There is an attached member cantilever part with in this cantilever portion there is 10 kilonewton per meter load, 3 meters long, and let's transmit the effect of this to the beam at B. Then 20 kilonewtons concentrated or point load at C. And finally, in portion D, we have a uniform load of 15 kilonewtons per meter. So of course, the weight of the beam is negligible compared to the load shown. So first, let's have to transmit the effect of this 10 kilonewton per meter load. 10 times 3 is 30 kilonewton loads. Then from principle in statics, we have to add 30 downward and 30 upward at B, and noting that this 30 upward kilonewton load and this 30 kilonewton downward load equivalent to this load here will constitute a couple of magnitude 30 times 1.5, half of 3 meters. So 30 times 1.5 is 45 kilonewton meter, which is clockwise as shown. So we now remove this and this attached portion of the beam, and the beam now consists of a portion 4 meters from A to B with varying load, triangular load from 0 to 36 kilonewton per meter. At B, we have 30 kilonewtons downward from here and a couple of 45 kilonewton meter, which is clockwise. At C and portion DE, it remains. So we solve for the vertical reaction at A. The horizontal reaction is 0, obviously. So summation of moments about E equals 0, clockwise positive. We have AY times 10. The length of AA is 10, 4, plus 3, 7, plus 1, 8, plus 2, 10. Then plus the couple 45 kilonewton meter. Then equals this triangular load here, 1/2 of 4 times 36. So it acts here, the centroid, and that distance is 4/3 plus 6. So that's why you have here 4/3 plus 6. Then plus 30 kilonewtons times 6. 30 times 6. Then plus 20 times 3. 20 times 3. Then lastly, plus 15 times 2 times 1 moment arm. So solving for AY, it is 75.3 kilonewtons. Likewise, summation of moments about A equals 0, counterclockwise positive, so counterclockwise equals clockwise moments. So we have RE times 10, then plus 45, plus 1/2 of 4 times 36, and 2/3 of 4 is 8/3, plus 30 times 4, plus 20 times 7, 30 times 4, 20 times 7, then lastly 15 times 2 times 9. Solving for RE is 76.7 kilonewtons. So we now construct the shear diagram, shear force diagram. So beginning with 0, because AY is 75.3 kilonewtons, we go up to 75.3. So we have here to level 75.3. Shear diagram the ordinates, the units are in kilonewtons. Then from A to B, the area of this triangle is 1/2 negative because it's going down. 1/2 of 4 times 36, so it's negative 72 kilonewtons. So 75.3 plus negative 72 is 3.3. Now, how do we connect these 2 points with the shear curve? So you describe the change in ordinates or change in loading above. It is from 0 to negative 36. So it is from 0 and it is increasing negatively, meaning the ordinates is increasing negatively. Interpret it in the shear diagram as the slope of the tangent is increasing negatively. Or the other way is, because the intensity of the load here is 0, the slope of the tangent in the shear diagram is 0, horizontal. And at B, just to the left, it is negative 36. So if this is the slope, that red, that orange line there, if that represents negative 36, so we connect these 2 points with a smooth curve that will be tangent to that horizontal line and tangent to this inclined line with slope negative 36. So this is the curve, unless it is a straight line. Then, because we have a concentrated load of 30, so 3.3 minus 30 is negative 26.7. There is an abrupt change, so negative 26.7. Then between B and C, there's no load, so that means the shear curve, the shear force is constant, negative 26.7. Then at C, there is a downward force of 20, so from negative 26.7 minus 20 is negative 46.7. Between C and D, there's no load, there's no change in shear, so it's just horizontal. So this remains negative 46.7. And between D and E, there is a load. So the area is negative 15 times 2, so negative 30. So from negative 46.7 plus negative 30 is negative 76.7, which checks because RE is 76.7. Then since this is 0 degree, the slope of the shear curve is straight line. So all you have to do is connect these 2 points with a straight line. So that's it for that shear curve. Now for the moment curve, area 1 is area of parabola, which is 2/3 base times height, plus area of this rectangle. There is a rectangle of height 3.3. So this is the calculations. Area of parabola is 2/3 base times height, while spandrel of parabola or complementary parabola, which is this, is 1/3 base times height. Because it is a parabola, it is 2/3, base is 4 meters, height is 72 meters, where 72 meters is the difference between 75.3 and 3.3. In other words, this is the height of the parabola, 75.3 minus 3.3. Then plus area of the triangle 4 times 3.3, area 1 is 205.2. For the rest of the areas, rectangle and trapezoids, there's no need to show the calculations. You know the areas. So for instance, area of this rectangle, negative 26.7 times 3, negative 80.1, negative 46.7 times 1, negative 46.7, then 1/2 of quantity trapezoid. 1/2 of quantity, negative 46.7, plus negative 76.7, times 2 is negative 123.4. So another way of computing area 1 is based on the shear equation. So the shear equation, this is the portion of AB. Then we want to generalize the shear equation from A to this point X here. That distance is X. and the intensity of the loading at that distance is W. So let's enlarge it here. So this is 75.3 x, then the triangular load, and by similar triangles, W as to x equals 36 kilonewton per meter as to 4. So that's why W is 9x. So that's why I represent it with 9x. This is the positive shear direction, V. That's the positive moment counterclockwise about the right section, for shear downward for the right section. So summation forces y equals 0. Downward force equals upward minus downward, or downward plus downward equals upward. So that's why downward force, shear force, which is assumed to be positive, is 75.3 minus 1 half of x times 9x. So that's why you have here, by integration, area 1, we have the strip in the shear diagram. The area of the strip is shear, which is quantity 75.3 minus 1 half x 9x. That the shear, then the thickness is dx. Integrating from 0 to 4, then that represents the entire area 1 dx. So using your calculator, it will give you the same value of 205.2 kilonewton meter. So to continue, now that we know that the area is 205.2, the moment at A, because this is an end support, pin 0, then it is plus area 1, which is 205.2. So this is approximately 205.2. To connect these 2 points with a curve, moment curve, describe the change in ordinates above, interpret it as the change in slope of the tangent below. So from positive 75.3 slope, then it reduces to 3.3 slope. So positive 75.3 is almost a vertical line. Then 3.3 slope is, let us say, that one. Then connect these 2 points with that smooth curve tangent to this initial tangent here, then tangent to the tangent. So the slope is positive. From positive 75.3, it decreases down to 3.3. So I hope that there's no more problem about the curvature of the curve. Describe the change in ordinates above, interpret it as a change in slope below. So it is positive decreasing, that's positive decreasing slope. Next is, we have 205.2. There is a couple, concentrated couple of 45 clockwise, which is positive. So 205.2 plus 45 is 250.2. Then from 250.2, we have uh, plus negative 80.1. So 250.2 plus negative 80.1 is positive 170.1. Since this is 0 degree, we connect the 2 points with a smooth curve, which is equal to this line here. So this curve here. Then from 170.1 plus another area, negative 46.7, that's 0 degrees, so it's just a straight line. 170.1 plus negative 46.7 is 123.4. So we simply connect these 2 points with a straight line. And finally, we have first degree negative slope, second degree. So area is negative 123.4. 123.4 plus negative 123.4 is 0. And that is expected at the moment is 0. Now to connect these 2 points, 123.4 and 0 here, describe the change in ordinates above from negative 123.4 from negative 46.7 to negative 76.7. It is negative ordinate, and it changes constantly to negative 76.7. So it is increasing constantly from negative 46.7 to negative 76.7. So it is negative increasing slope So that's negative increasing slope. Or we draw the initial slope, which is the slope of that line. Then the slope at this end is negative 76.7, almost vertical. Then we connect them with a smooth curve. And that's the smooth curve. So that's it. This is the moment diagram for that beam.